Okay, so let's continue. I said that we'll do some math in this particular module, as I said in the towards the end of previous video. So let's look at some of this math. So very simple calculation just to illustrate the concept, and then we'll have a simple calculation, then we'll add up a more difficult one so that you see how things are worked out. So first of all, when you try to design a landfill, it has to be, we have to come up with a size, isn't it? We need to know the size of the landfill. So how will it come up with the size of the landfill? First of all, say if I want to, I'm sitting in Kharagpur right now at IIT Kharagpur campus. So if if the Kharagpur town, IIT Kharagpur is a too small place for a landfill, but if Kharagpur town wants to build its own landfill, so first of all it has to know how much waste is generated in Kharagpur town. So we need to know what is the total waste generation in town. The population of the town may change over time, and will change over time. So how the waste quantity will change, because as I said, the landfill is not designed for say 1 year or 2 years. Usually we are looking at a landfill design for 20 years, 25 years. So we need the size of the landfill based on those projection over 20-25 years of population, 20-25 years worth of waste generation. The waste generation rate may change over time as well. So for all these aspects, we have a manual prepared, which is known as, some of you who are working in environmental field, you know those that we have a CP, let's see, we have this CPHEEO. CPHEEO, Center for Public Health in something, that's the organization which put together the manual. That manual is there for water, manual is there for the wastewater, the manual is there for the solid waste. So all these things are like it's incorporated in that manual. So that they did talk about that. So as per the CPHEEO manual, the typical waste generation rate for an urban center is taken as 0.6 kg per person per day. So that's for the urban area. For the rural area it is less. So that 0.6 kg has been arrived at based on certain calculation. So similar certain measurements on site. So and that number is proposed. That number may not be same throughout India. Even within the urban centers, things may be different. So it's always better to do some sort of data collection on your own. So if you are going to design a landfill, of course you will go for a DPR, the detailed project report, which needs to be prepared. Usually it is done by certain UL consulting firms. Recently we were involved in looking at several DPRs from many ULBs in the country, which I had a chance to review, and that again some of they had some issues. Of course, that's as a waste management expert, that's our role to identify those issues and highlight those issues so that the DPRs can be improved. But most of these DPRs that we have looked at, they had gone to do the sampling, higher income group, lower income group, medium income group, different houses, different localities, different socioeconomic status. So all those, you collect all the data, and then you come up with your per capita generation rate. For most part, you may find numbers to be similar to 0.6 kg per person per day, but not always. You do see that numbers do fluctuate. So once say we have that number. So I gave you that background because we will use certain. So we have that number. Now we need to find out how much area will be required. So to find the area for the sizing of the landfill, we have to know the equation for the volume. It's the volume. So just for a very simple rough calculation, this first problem is not actually what you will typically do in a landfill. This is a very preliminary calculation that you may do. So if you have this length, certain width and certain height, and we are using more like this particular shape, and you very well know this is not the typical shape of the landfill. Typical shape of the landfill is like this, and then and you will have like a base is different. The width of the base and width of the width at the base and width at the top is not the same, and there is a side slope as well. But for a very simple calculation, just to have a rough estimate of how much acres will require, we can use this approach. So you have the volume is length times width times height, which we know. So that's so based on say if the footprint of the area of the landfill is 1000 feet by 750 feet. So you have a 1000 feet length, 750 feet is your width, anticipated depth is 30 feet, what will be the volume in yard cube? So we can always convert that to meter as well. So that is your job as your assignment for you to convert these from feet to meters. I could have done that, but I wanted you to do it because and I will give you some numbers here which you can use. 1 feet is 12 inches. Let me use this pen. So 1 feet, sorry, we have 1 feet is 12 inches, isn't it? And 1 inch is equal to 2.554 centimeter. So that's the 1 inch is 2.54 centimeter. So that's the it's a 1 feet is 12 inch and 1 inch is 2.54 centimeter. So you can convert from feet to this, and 1 yard is 3 feet. So from that you can convert all this yard cube to feet cube to inch cubes and centimeter, meter, and all those conversion can be done based on that. So you can pause the video at this and write down these numbers, and then you can do all those calculations. So it's if this is the footprint is given in this feet by this, anticipated depth is 30 feet. 30 feet is almost like a 3-storied building. So typically 10 feet is like a 1-storied building. So what is the volume in yard cube? So we know length times width times height, so you got the volume. So this is the volume. Again, we are using it no slope, nothing, just a very simple calculation just to kind of estimate the area. So we got the volume. Now how we can use this volume? We can use this volume by so here we are not considering the side slope, but in the actual condition when you will be doing the volume calculation, you will have the side slope, isn't it? We talked about the landfill has a side slope. So the analysis that we did in the previous slide, we did not calculate this side slope. This analysis did not consider the side slope, but then actually the side slope will be there at the landfill. So how we describe the slope at the landfill? It's that any slope, as you can see, is your horizontal. We do it actually in a reverse way. So when we say slope of 2:1 or slope of 3:1, essentially we are talking about as 3 is the horizontal distance, 3 unit is the horizontal distance when 1 unit is the vertical distance. So when we say 3:1, 3 is the horizontal distance and 1 is the vertical distance, and this is in units, in any one particular unit. It could be 3 feet, 1 feet, 3 meter, 1 meter, it's the same, slope is the same. So that's the side slope, and typical side slope is 3:1 when you have 3 horizontal with 1 vertical. So that's the typical side slope that we use for a landfill design. So here, as you can see, you have 30 feet. So we have 30 feet here. So this would be 90 feet in the horizontal. So it's the 3:1 slope, and 3:1 slope is what you will see most common. Say in the exam problem, any exam you are taking where the side slope is not given for the landfill, you can take 3:1 as the side slope, because that's the most common side slope used in landfill industry throughout the world. Right now the Bhalaswa landfill actually is almost like a 1:1 side slope, which is really dangerous. The way during every rainy season, some of these landfills that we have, I should not, again I am using a wrong word, I should not call them landfill, they are the dump sites, because since we are teaching an engineering course here, that's from the engineering point of view, they are essentially dump sites. So some of these dump sites, the slope is almost like this. So it's almost 1:1, and that every rainy season, I'm really worried about as a citizen of the country. I'm always worried of some catastrophe that may happen from those dump sites, because if it rains a lot, luckily, say for example in Delhi, it does not rain as much as rains in Kharagpur or in Cochin, so we don't see that thing happening. But if it rains a lot, that this slope can collapse anytime. This past rainy season, we had that incident happening in Ahmedabad, where one of those dump site actually collapsed and the garbage came on the roads. So that no fatalities, but some places it can cause fatalities as well. So that's we need to be careful. So here a 3:1 slope is used. That's the typical slope. You can If slope is not provided in your math problem, you can use 3:1 slope. That's there is no harm in that. You can do that. So and then so its slopes are sometimes referred also in percent. So that's another way of putting percent. So 3:1 slope, we call it 33%. 3:1 slope is 33%, and 4:1 slope is 25%. So it's the slopes 3:1 slope will be 33. So more common when describing the shallow slopes, when you have a shallow slopes, it's more common to describe in that way. So that's it's a 3:1 or 4:1. That's in describing the shallow slopes. So how do you factor side slopes into the volume? So this is how the typical volumes are. Initially when I told you that LWL times W times H, that's the very simple way of just doing a rough estimate. But when you are doing the actual problem, this is what we will do. This is the actual so when we are trying to do the actual problem, this is what we need to do, where this is how the landfill looks like. This is what you see on this picture. And then you have the length, you have the width. So we have the length of the landfill, we have the width of the landfill, we have the height of the landfill. So we take all these three and based on, so this L times W times H, that would be if there was no side slope and the top was same as the bottom in terms of the width. But since the top and bottom is not the same, we have a certain negative factor, and then certain things has to be added. And again, you can just draw the geometry, and there are derivations of this formula out there, and you can derive it by yourself, or you can just trust my word on it, and you can do this. But this is a simple geometry here, simple geometry where since we have the side slope, so we are losing some space. The top is not top length and width, the width is the same, top length is not same as the bottom length. So we have differences there as well. So based on that, we can calculate, and this is how this will be for this particular shape. This is what we get in terms of the volume calculation. So here L is length, W is width, H is height, and S is the side slope. So this S number, we call it for 3:1 slope, S is 3. So if the 3:1 slope, S will be the 3. So now using those information, if we can do this calculation again, here we had 1000 feet length, 750 feet wide, and 30 feet long with the S of 3, with the slope of 3, we get, let's see, oops, sorry. With a slope of 3, what we are getting here is if we can plug those numbers in here, we get volume as 660,000 yard cube. If you remember from the previous slide that we did for the very rough calculation, if you go back to there, and here we got the value of 833. So it was much higher, isn't it? It was much higher, almost, but just to get a rough estimate, but it was much higher, 660 and 820, so almost like 20 some percent more, but it gives more. We know that it will give more, it will not give, will be less. So that way we have some control. So in terms of it, we are more conservative in those calculations. So that's once you have the volume, then there is another term which is called landfill capacity. Landfill capacity term is used in many calculation. It is essentially the years is the time that the landfill can receive waste at a given waste filling rate. So we talked about the waste filling rate earlier, that as per CPHEEO manual 0.6 kg per person per day, or as per your calculation that you do, or if you are a city, or if you are a like a big metropolitan area, whatever agency you are, if you are a student who will essentially work on those departments, you will get the DPRs made, or either you may be making a DPR as a consultant. So based on what role you play, once we know the actual waste generation rate, and also we predict how the waste generation rate will change over time, and there is a way of doing it, and then we come up with what is the waste filling rate. So how much waste will get filled per year in the landfill, So if we know the volume of the landfill, and so we know the volume of the landfill, we know the waste density because the waste will be compacted. So what will be the waste, how much tons will be in 1 yard cube, because we do the compaction on top of the landfill, and then if we divide it by the waste filling rate, that gives us the capacity in year. And always when you do this type of math, check the units. So here we have yard cube, that's the volume is given in yard cube, here tons per yard cube, so this yard cube and this yard cube will cancel out. We have tons on top, so this ton and this ton will cancel out, and since now here we have 1 upon year, so this year will go on top, so it will basically become year on this side, and then we have year on this side. So the units on both sides has to be the same. So that's, we should check it. So landfill volume times the waste density. So essentially on top what we have the mass. This is the mass. On the bottom what we have? In bottom we have the mass that is coming per year. So top we have the total mass that the landfill can take for the volume it has. Bottom we have the waste, how much waste will go into the landfill per year. So when you divide it, you get the year of the capacity in terms of the year. So in this calculation, if we do a math in terms of a hypothetical scenario, where for the previous landfill volume, which 660,000 yard cube, what would be the capacity in terms of years of the landfill if C&D debris waste, this is a C&D landfill for example, accepts 500 tons per day, and landfill debris density is 1500 pounds per cubic yard. So we have pounds per cubic yard, this is the density given to us. We can, again, you can convert everything to kg per meter cube and all that. I gave you the conversion unit. 1 pound is 453.6 grams, or 1 pound is 453.6 gram. I will, in the solved example problems that we will have the TS do it, we will use the SI unit, so don't worry. And so this is the only problem where we are using the British unit. Just to, I want you to practice that as well, because in most of the books that you will get, because most of the books that are written in US or they still use these units. So this just to make you familiar with this unit system we are using in this problem. But before, in the previous videos that we have already seen, we have always used SI unit, and the later videos will also use SI unit. But just to give you a feel of, there could be other units out there when you are doing problem, how to convert. So, and I want you to work on that conversion on your own, and you should get the same answers, because if your conversion is correct. So here we had 660,000 yard cube. So that's the volume of landfill that we had. 1500 pounds per yard cube, that's the that's the density. And then 1 ton is 2000 pounds. This ton is a US ton. So US ton is actually smaller. So actual, because 2000 pound will be close to 900 kg, not 1000 kg. So based on our conversion rate here. So it's US ton is a smaller ton. So 1 ton is 2000 pounds. So it's based on the US ton, because this is also based on US ton. So you have 500 tons per day, and then 365 days in a year. So if you do this math, you get the capacity as 2.7 years. Now 2.7 years, does it really sound ridiculous? Isn't it sound ridiculous? Because what I have been saying so far, we make landfills for 25 years, we make landfill for 30 years, and here I am coming up with a value of 2.7 years. This was done on purpose. The numbers that I chose, this, as I said, it's a hypothetical scenario. The number I chose was on purpose to illustrate this point. Actually, in a classroom setting, I expect the students to raise their hand and say that this is insane. How can you have a capacity of 2.7 years? And that's because if you are designing something for 2.7 years, it's really bad. It's a bad design, because it takes a lot of effort to design a landfill, and you don't want to do it for 2.7 years. You would rather do it for 25 years or 27 years. So, but the numbers chosen in this problem was to illustrate this point. It's we need to think as an engineer. But as an engineer, as a math, this question is correct. But as an engineer, this numbers doesn't make sense, because 2.7 years is ridiculous in terms of the capacity of a landfill. So just to illustrate that point. And but because what happens is, even as I teach several engineering courses, and I see people designing certain things, and then they will round it off, and when you round it off, say diameter of the pipe came as at 25.4 millimeters or centimeters, and then they round it off to 25 millimeter. So you cannot do that. You can make it 26, you cannot make it 25, because 25.4 is what you need. So you can go higher. So as a math question, you can make it 25 from 20.5 to 4, but as a engineering question, you cannot make it 25. You have to actually go to 26. So those to illustrate those kind of concept, here the numbers were chosen to tell you that it's a bad choice of number. And in the real world, if you see this kind of data coming out, you have to really go back and check your math. It should not come out. So being said that, we'll look at some of the other aspects of so this was some of the basic landfill design, and again we'll have some more math problems coming up as example problems later on. So now we'll look at into more in terms of the management part or the regulation part. So when we try to site the landfill, there is a facility siting, we have to select the location of the waste management facility. So there are several issues are there. There are regulatory issues, there are environmental issues, there are economic issues, social issues, political issues, and all those things, different factors are taken into consideration when we are trying to site a landfill. And so it's in terms of the regulatory issues, so there are some regulation place restriction on where the facility might be located. We don't want it close to the landfill, close to an airport, because the airport, it's totally no-no. We don't want it close to an airport, not close to a floodplain, wetlands, fault areas, seismic impact zones, unstable areas. So for all these different places, for some it's an obvious thing. We know that we don't want it near the seismic impact zone. If sometimes we don't have any other choice, and we do have several dump sites in India which is on seismic impact zones or in unstable areas, or even close to even wetlands. But as per regulation, we should not have, when we are going for these engineered landfill, as per the waste management rules of 2016, it has certain restriction on where the landfills could be. So airport, why we don't want closer to the airport. So if you go to an airport, you have so many. If you go to like a waste disposal site, it attracts lots of birds, and these birds can create a nuisance for the aeroplane flying in and flying out. So that's why we don't want it closer to an airport. So most of the stuff, whenever you, again, I keep on saying this again and again in all the classes that I teach, whenever you have anything put forward in front of you, always think about what is the rationale behind it. Why we are doing it? Why not closer to the airport? What is the problem with the floodplain? The problem with the floodplain is that you will have the water coming in there, and the water will percolate into the landfill, and then you will have huge leachate problem, and you will contaminate the surface water. So you don't want it to closer to those places where there is a lot of environmental nuisance, because the job of the landfill is to have an environmental control. So we need to select those areas which are more suitable. Wetlands, again, very close to a water, it's a bit better to avoid that. Fault areas, seismic impact zone, unstable areas, again those can create landslide. The garbage slide, so you will have a huge garbage slides happening because of a earthquake or something happening in that area. So those things we need to take into consideration in terms of this. That's why from the regulatory point of view, we have those things like highlighted over there. So that's the regulatory issues, and then there are environmental issues. So in terms of the environmental issues, we have contamination of groundwater, contamination of air, contamination of soil, destruction of sensitive land. So all those things are there, which we need to look at in terms of like how to so in terms of their impact on environment. So contamination of water, contamination of air, contamination of soil, those are very, very important. Contamination of water, groundwater, surface water, and that's it's like a critical in terms of in terms of evaluating the environmental performance. So we have to be careful in terms of the groundwater contamination, we have to be careful in terms of the surface water contamination, air contamination, soil contamination, and also destruction of sensitive lands. That's why we don't want it closer to a wetland, unique habitats, wildlife, dust, noise, odor, smell. So all these environmental issues has to be taken into consideration when you're operating a landfill. So that's for the contamination of groundwater, contamination of water. We have this groundwater monitoring system. We have this stormwater protection system in place, which takes care of that. Contamination of air, you have a gas collection system, and at many places you may have some odor removal system as well. Contamination of soil, especially the subsurface soil, if the leachate collection system is working properly, if the liner system works properly, we should not have the soil contamination issues. And we have to be careful in terms of the sensitive land, wetlands, and all that, and the impact on wildlife. So those things are always has to be looked into. So that's in terms of environmental issues. Then we have the economic issues, you want this location to closer to the waste, because as we have been talking about, the collection of garbage is one of the most the waste collection is one of the most costly affair. So collection of waste is one of the most costly affair in terms of as part of the waste management system. So the economic issues in terms of the location of facility relative to the source of waste, the price of land, and if you are producing certain materials, what is the distance to the market. So those things has to be looked at, the cost of labor, infrastructure, if you have to improve the infrastructure a lot, if you have a site which has some clay, so which can act as a liner, but may not be very suitable, but you have another side which seems to be a little bit better suitable, but you have to spend a lot of money in terms of bringing the clay in. So all those things it impacts your cost, impacts in terms of the economic issues, in terms of and if the site capacity, say if you are trying to design a landfill for 25-30 years, but the landfill, you cannot design it for 30 years because you don't have that much land available. So all these land prices, if closer to the city area, land prices are more. If you go further from city area, the land prices are less. But if you go further from city area, your transportation cost goes up. So you have to do a very detailed economic analysis in terms of for the selection of the site. So location, how closer better, the price of the land, market distance. If you're producing, if at the landfill site, if you're producing gas, so landfill gas to, if you're trying to have a landfill gas to energy, and then you're trying to connect it to the grid or supply it in a local market, so you should have a local market. If you're trying to use that landfill gas directly for some purposes, so gas, it should be, the gas should be, so the market should be available. So those things goes in consideration in terms of selecting the site. Social issues, less disruption of quality of life, since people there are people around it, so you want less disruption, reduction in the property value. So if you are making it closer to a, that's why people don't want it, that's a NIMBY syndrome, not in my backyard, is one of the major reason is people don't want their property price to go down. Because if you build a waste disposal site or the waste treatment site, it gets although most of these sites can be run in a very professional way with a very limited impact on the surrounding area. And if you go to countries like China, they have done that, and it looks, even in many European countries, which I showed you some pictures of waste to energy plant in Austria and other places, which is kind of in the middle of a downtown or middle of other things happening around it. But there is still a negative mindset that if you have a waste disposal, that will be dirty, lots of trucks will be, and some of them is true. So a lot of truck will be coming in and coming out, waste may be flying around, and you will have a smell problem and all those kind of things. And that's what people are worried about in terms of their quality of life, property value. So that's why the NIMBY that we have been talking about, which I have mentioned earlier as well, that NIMBY syndrome, not in my backyard. Syndrome is there in terms of the waste disposal. Then environmental justice, you should not throw the waste in an area which is less where like a vulnerable population is, poor people are there. so that's not proper to do it. Say that should not be done, because everybody should have access to like a clean air. So if you don't want to dump, that's happening. Like the issue of the Bangalore landfill in the outskirts of Bangalore, the villagers protesting. That's because that's an environmental justice issue. Similarly, in Kolkata near the Dhapa area, the new settlement of many people which were moved from Newtown and other places to this area, and that is, even when you drive by the car there, you smell so much. So think about the people living close by. So there is an environmental justice issue also there in terms of waste management. And then you have to make sure there is you don't destroy any historical, cultural and archaeological significant areas. So those things are also very, very important. So these are different issues that needs to be considered when you are trying to select a site. And of course, there is a political issue. We'll not talk about too much, but for a good or a bad, politics does play a role. It is often common to find a solid waste facility, and that's true globally. Facility in location with the fewest number of voters, which is and one way it is, I think there is no problem as long as it doesn't impact the people, as long as all the other technical and other consideration is taken care of, because whichever political party is in power, they would like to take care of the interest of the people who votes for them. So, and then we'll go into the siting process in the next video. So let's wrap this video here. So what we have talked about in this particular video, we did the math. I showed you a very simple calculation which was way off, a little almost 25% off, but it was a higher number. So at least you get some idea of what is the requirement of the area. And then we did the actual calculation for the volume. We calculated the volume. Then we also looked at a hypothetical scenario of a C&D waste disposal where we calculated the capacity. The capacity number was absurd, so you will not have that kind of capacity coming up. If it comes up, you need to revise your design. That's not so I highlighted that very clearly in the video. And then we talked about how to do the siting. So then it's how to select the site, and we are kind of in the middle of that. So we'll continue that discussion in the next video as we continue. So with that, let's close it here, and I look forward to seeing you again in the next video. Thank you.